Hello again. Welcome to another lesson in geometry. Today we are covering section 10-7, areas of circles and sectors. So you're going to find this familiar to our last section where instead of computing the arc length, we're going to compute the area of part of the circle using the arc. Okay. So explain how the area of a figure is different from the perimeter of a figure. So area is a measure of space inside the figure. And perimeter is the distance around the figure. Okay, so one of them we're looking for a bunch of little squares that will fit inside, and the other one we're just looking for the distance around it. So a distance versus an area. Okay, so circle the formula for the area of a parallelogram. That's going to be our first one. Remember, this is a triangle, this is a trapezoid, and this one's a kite. Okay. Find the area of each figure, so we just have some review here. The area of a parallelogram is going to be the base times the height, so this will be 3 times 5 for 15 meters squared. The area of a triangle is 1/2 the base times the height, so half of 6 will give me 3, and 3 times 9 will give me 27 centimeters squared. And the area of a rectangle is the same as a parallelogram, it's just base times height, so this is 60 feet squared. All right, so we have a vocabulary builder here. Sector. A sector of a circle is a region bounded by the arc of the circle and the 2 radii of the arc's endpoints. So this is a sector right here, sector RST. So we have the arc from R to T, and then bounded by the 2 radiuses RS and ST. Okay. So the area of the sector is the fractional part of the area of the whole circle. So last time we found the length of the arc by doing the fractional part of the circumference of the whole circle. This time we're going to do the fractional part of the area of the circle. All right, so name the arc and the radii that are boundaries of the shaded circle. So the arc is AB, and the radii are AC and BC. Okay, those are our 2 radii. Circle the name of this shaded sector. So this is going to be sector ACB. You need to put the center in the middle of the name of your sector. Okay, so the center point always goes in the middle of your sector. So the shaded sector is what fractional part of the area of this circle. So what fractional part is this one going to be? Well, it's going to be 1/4 of the circle. You can see that really easy, but how did they get that mathematically when it doesn't easy to see, when it's not easy to see? And that's this. So the central angle, ACB, is equal to 90 degrees. That's shown to us. So the measure of my arc, AB, is going to be 90 degrees also, or 90. Okay. And then we want to know what part of that circle is it. So that's 90 of the 360. And if we reduce that, you'll get the same 1/4 that we could just tell by looking in this case. Okay, on page 2, we have theorem 10-11, the area of a circle. And most of you already know this already. The area of a circle is pi times the radius squared. And remember, that's how many squares would cover the circle. And because the pi is irrational, most of the time we're not going to be able to find an exact answer for this that doesn't have the word pi in it, or the symbol pi. So if the radius is 5 feet, then A is equal to pi times 5 times 5, radius squared. If the radius is equal to the diameter, is equal to 1.8, then the area will be equal pi times 0.9 times 0.9 squared. All right, so what is the area of the circular wrestling region with a diameter of 42 feet? So the radius of the wrestling region is 21 feet, half of the diameter. Complete the reasoning model below. I can use the formula for area of a circle, pi r squared, and I can substitute the radius into the formula and then simplify. So this is going to be 21 in this case. And 21 squared will give me 441 pi. So that's our exact answer. And then we can use a calculator to estimate that. So that would be about 1385.44236. And we're going to round that to the nearest foot squared, so this will be about 1385 feet squared. All right. Then we have theorem 10-12, the area of a sector of a circle. So we want to find the area of this shaded region here. Okay. And the way that we do that is we just do the product of the ratio of the measure of the arc to 360, so find the part of the circle you want, times by the whole area of the circle. So very similar to what we did for arc length. We find the same ratio we did for arc length, but instead of multiplying by the circumference, we multiply by the area. All right. So complete each. The measure of the arc is 60. We want to find the area, or the measure of the arc and the area of the sector that goes with it. So the measure of the arc is 60. Then it's going to be 60 over 360, which will give us 1/6 of the circle is what we want. And then to find the area, we would do 1/6 times pi times whatever the radius squared is. If the central angle was 120 or the arc was 120, then this would be 120 over 360. 120 there, which would give us 1/3 of the circle we want to find the area of. So 1/3 times pi r squared. All right, let's flip it over and take a look at page 3. Okay, on the top of page 3, we have problem number 2, finding the area of a sector of a circle. So a circle has a radius of 4 inches. So let's draw this circle. All right. What is the area of a sector bounded by a minor arc of 45 degrees? All right, so we know that our arc length here is 45 degrees. Okay. All right, so we want to find this area in here. All right, so at the right is one student solution. What error did the student make? All right, so let's see. First, they found the part of the circle they wanted, which was perfect, 45 out of 360. And then we're supposed to times that by the area of the whole circle, okay? But the problem is they didn't times by the area of the whole circle because they found the area of the whole circle incorrectly. They forgot to square the radius. So the student did not square the radius. So we have to redo the problem here. And remember, we want to leave our answer in terms of pi, so we are not estimating this time. So we're going to do this. We want to find the area of the sector. That's going to be 45 out of 360 again, times by the pi r squared. And in this case, r is going to be 4. So 4 squared. And if we work that out, 45 over 360 is 1/8 of the circle, okay, times pi, and then 4 squared is 16. So 16 times 1/8 will give me 2, and then we just put the pi back. So the area of this sector will be 2 pi inches squared. All right. Now we have a new thing here, the area of a segment. So the area of a segment is the difference of the area of the whole sector and the area of the triangle that's formed by the radii and the segment joining the endpoints. So this is a segment. It's kind of like a cut-off piece of our circle, okay? And what we do is we find the whole sector that uses those two endpoints, same endpoints here and here. And then we find the area of the triangle part we don't want, that green thing in there, still uses the same endpoints here and here. And if we subtract them, we get what's left, which is what we are looking for. Okay. All right, so problem 3, finding the area of a segment of a circle. So we want to find the area of that yellow piece out over here. So what is the area of the shaded segment shown to the right? Round your answer to the nearest tenth. So use the justifications below to find the area of sector PQR. So the area of the sector, that means the whole thing. So all of this stuff first is going to be equal to the arc, which was 90 degrees. So there was a 90 here, so our arc is also going to be 90 over 360 times pi r squared. So 90 over 360 times pi, and our radius in this case was 4. So that's 1/4 times 16. Okay, so 90 over 360 will turn into 1/4 times pi times 4 squared is 16. No squared on there anymore. And then 16 times 1/4 will give me 4 pi. So that is the area of the whole sector. Now, PQR in here is a right triangle. So now we're going to find the area of just the triangle parts. We can subtract them. It's a right triangle, and it has a base and height that are both the same numbers. So the base and height are both 4. All right, we have to flip it over to the next page here. So find the area of triangle PQR. So the area of triangle PQR is equal to 1/2 times the base times the height, which is 1/2 times 4 times 4, the two radii multiplied together. So 4 times 4 is 16, times by 1/2 will give me 8. So to complete the area of the shaded segment, so just a little corner piece over there, you're going to do the area of the whole sector, which was 4 pi, subtract the area of the triangle piece we don't want, so 4 pi minus 8. And then we're going to type that on our calculator here, which will give us about 4.5663706, a whole bunch of other stuff. Okay, and then round it to the nearest meter here, or square meter is going to be, round it to the nearest tenth of a square meter will be 4.6. All right, so last thing we have here is a lesson check. As always, pause the video, try the lesson check yourself, and then come back and see what you knew how to do. Okay, welcome back. Hopefully you've tried the lesson check already. So suppose a sector in circle P has the same area as a sector in circle O. So here's circle O, and here's circle P. And we have two sectors here. Circle O, we have this shaded sector in here that's gray. And in circle P, we have this shaded sector that's kind of yellowish. Okay. Can you conclude that then a circle P and circle O have the same area? And we want to explain. So we're back to doing sectors instead of segments like the last example. And we want to find the area of the sector in angle AOC here. So we want to get this piece. What's the area of that? All right. So that's going to be the angle we want out of the total 360 times pi, and then our radius squared is going to be 8 squared. All right, so that's going to be 1/8 pi times 64, which will make 8 pi for our area. All right, and our second one, we're doing this. We have an arc of 180 out of a total 360. Times by pi, and the radius here is 4, so 4 squared. Okay, so this is going to be 1/2 times pi times 16, which gives us an exact area of 8 pi also. So our sectors have the same area. Do the sectors have the same area? This is yes. Can you conclude the circles have the same area? This is going to be no, and why not? Okay, the why not is they have different radius. Different radii. Okay. If they have different radii, then they're going to have different areas. So remember, area is found by doing pi times the radius squared. So one will be pi times 8 squared, and the other will be pi times 4 squared, which will definitely give us different areas. All right, so check out the vocabulary words that you understand. So we learned about a sector of a circle, and we learned about the segment of a circle. And if you don't know the difference between these two, you need to go back and watch again. And I think you already knew the area of a circle, so that shouldn't be a problem. So how well can you find the area of a circle, the area of a sector of the circle, and the area of a segment of a circle? Because that's what we'll be practicing in class next time. If you are not in here, you want to make sure that you go back and watch again. and remind yourself how to find those. The tricky one, I think, is the area of a segment. Okay, and we only saw one example of that.